Good afternoon, everyone. Good afternoon. Can you hear me? Okay, thank you. My name is J.C. Lin. I'm Vice President of the Ethernet Product Group in Mikrel. Today, I'm honored to be here to share with you some of the things we have done so far in Ethernet business and emerging market that I'd like to share with you. First, I'd like to start with the history of Ethernet. What is Ethernet? Ethernet was invented in 1973 by Robert Metcalfe and was patented in 1976. In the early days, if you look at the patent, the original patent drawing, this is the bus, and these are the transceiver, and these are the controller, and this is your terminal, the PC that you use. And you could have multiple PCs share the same bus, and he called this bus Ether. And so this is the whole thing. If you look at it picture-wise, it looks like this. This is a bus with a multiple PC. And that's the reason why this network is called Ethernet. Okay. So if you don't remember anything I said today, I hope you remember this. And the disadvantage of this architecture is that everybody shares the same space, the same media. It's just like when I'm speaking, you have to listen because we share the same ether here. Okay. So when two people are talking at the same time, then we can't hear each other. So that same thing here, when two PC try to talk at the same time, this term called collision. So this kind of architecture is called carrier sense and multiple access collision detection. So every time before you speak, you have to listen. If somebody is speaking on the line, if nobody speaks, then you can speak. Okay? So it's more like courtesy. This was in 1985 that IEEE adopted this method, and this Ethernet became a standard in 1985. But after that, the Ethernet has been evolved along the same concept. The big breakthrough in 1997 is we come up with the switch, Ethernet switch. The previous diagram I showed you, everybody shared the same bus, so that you cannot talk at the same time, which is a big disadvantage for a network. So a switch, when this standard came out in 1997, it allowed you to do full duplex, means I can talk and listen at the same time. Okay. That means every one of the PC can talk to each other at the same time without facing a collision. And, but the main problem with this is if you have multiple PC, you want to talk to the same person, what will happen? So the switch inside basically have to store all the informations and then wait for the packet to go through. When this, for example, the station 1 and 2 want to talk to station 4, if the station 1 talk first and then section 2 talk later, the packet of station 1 will come to the station 4 first. And the other packet will come after that because all the information are stored in the memory, the packet memory. So the information is still there. It just delivered in sequence, in different, in the first in, first out kind of service fashion. And the other things you have to know with the switch is this switch has to operate faster than all these stations. Otherwise, it cannot handle the traffic. That's the reason why if we had 4 stations here, the switch, the bus speed of the switch has to be 4 times of the individual station. And when you need to have more people sharing the network, and you will see that this switch has to run faster and faster. Okay, so by 2000, IEEE come out with the link aggregation, means that you can cascade all the different switches, and then as long as the higher level switch runs faster than the lower level switch, then there's no blocking effect, means everybody can run everything at speed. And if you look at this picture, if PC running at 10 megabit, and the second switch, the switch here will have to run probably around 100 megabit. And then the next level will have to run at gigabit. So if you look at more, if you have bigger tree in your office, that means you need a bigger and faster switch. So over the year, for the last 24 years, you can see that Ethernet has been involved because all these requirements. I summarize all the standard in the IEEE's development in this chart here. And basically you can see that it divided into 2 parts. On the top part is the fiber media, and the bottom one is the copper media. And IEEE developments, they always had 2 tracks. One is fiber, one is copper. And the fiber is mainly for the WAN, the wide area network, and the copper is usually for the local area network. Okay. There's a couple breakthroughs I'd like to point out here. In 1990, the IEEE came out with the 10 base T. That's the T means a twist pair. Okay. That was the beginning of the 3Com and all this Bay network stuff. And by 1995, we have the 100 base T, which is called Fast Ethernet. And 1999, there's a gigabit Ethernet. And then 2006, just a couple of years ago, people had 10 gigabit twist pair transceiver. So you can see that over the time from 1990 all the way to 2006, this speed is really growing like crazy. And people even think that probably by next year, we should see 100 gig transceiver available. And in the middle, I try to show the Ethernet for the fast. You can call it first mile, or you can call it last mile. Okay. And in the metro and long haul, people use fiber. When they get to your house, they use passive PON or VDSL. And this year, we passed the 10 gigabit EPON. And this technology has been heavily used in Asia area, in Japan and Korea. And in addition to these standards, there's some other standard evolve along the way as well. If you see the one of the application back in 2000, 2003 is Cisco heavily promoted the IP phone. Basically, they like to use the phone as a network extension, and because everybody used to a phone that doesn't have a power. Because your old telephone, you can talk without plug in any power. Even though you had a power outage, your phone is supposed to work because the power is carried by the telephone wire. So you can talk at the same time and also deliver the power. So the same idea for the power over Ethernet is that you need to have a data and the power transmit over the wire through a 100-meter cable. And so your telephone, the IP phone, is power-free, and everything is supplied by the switch. And in 2003, IEEE passed the AO 2003 AF, mainly for IP phone application. And this year, they increased the power for the wireless access point, especially AO 2011N, and other security camera. If you look at the typical application of power over Ethernet, is that you can support IP phone, wireless AP, and IP camera. And you don't need the power to supply to these gadgets because like wireless access point, you want to place into the area that had the best reception. You don't want to put the place that limited by the availability of the AC outlet. Okay. And same thing for camera. The camera might be on the rooftop. There's no AC. But you can use the Ethernet cable to deliver the power. And at the same time, you can deliver the data as well. Okay. And over the years, you can see that IP traffic is really exploded. Actually, almost every 2 years, the IP traffic almost doubled. You can see that most of the traffic is actually from the consumer. It's not doing business work, actually. It's more like entertainment. You're streaming your video, movies, and music, and so forth. And this is a really huge requirement for the or burden onto the IP backbone. That's the reason why the standard has to catch up with this demand. And we had 100 gig coming next year. And if you look at the scale here, this is a petabyte is 10 to the 15 bytes. Okay? And if you combine all the written literatures, since we had all the languages, and together it's only about 50 petabyte, which is really tiny compared to what we are streaming every day. So you can see that the IP traffic is really huge today. And if you look at typical home today, I think everybody probably had this. You had your set-top box. At first, you had your router. You had your set-top box. You had your HD TV. You had your Blu-ray DVD. And they all connect by Ethernet. And you had the IP Wi-Fi phone. I think it's very popular in Korea. On one side is wireless, and the other side you have to connect to the router through Ethernet. Or you can use cordless phone, IP cordless phone, which is more popular in Europe, US and Europe. Same thing, your telephone is going through the gateway and go to the internet. I think, and some of the ISP even offer that $25 you can call worldwide. So it's really cheap because of this IP phone. And of course, you had your notebook, netbook, you had a printer, and you probably had a storage device connect to your network so that you can store all your pictures or your movies, your favorite movies in this hard drive. So everything is connected through Ethernet. What's the emerging market that we have today for Ethernet? One of the nature migration is to push everything you have in your living room to your car. Okay. So today in your car, there's a lot of entertainment system here. You had the navigation system, you had the DVD player, and sometimes you even had a DVD player at the back side of your car. And those are connected by a network. Today is called the MOST. That's called Media Oriented System Transport, called MOST. And the other bus inside the car, the CAN bus, this is more for control, critical equipment. And LIN bus is more some peripheral connections. And what we can offer for Ethernet inside the car is this. Today, we already had customers that are using this inside the car. The first usage is called the diagnostic port. And basically what this does is when you use today's car, especially the expensive car, had almost over 100 CPU inside the car. There's a lot of flash memory. And when you drive your car to the service station, the dealership, it takes them hours just to download all the information and try to figure out what's going on inside your car. And the download bus they're using is the CAN bus, which is running at 500 kilobit per second. Versus if you replace that with fast Ethernet, which is run at 100 megabit per second. So that's like 2,000 times faster. Okay. So instead of waiting for hours or days to get your car back, now the dealership can download this whole thing within just 20, 30 minutes. So that's a value added and save a lot of cost, money for the dealer, also save money for the consumer as well. So the next step is to look at the entertainment system here. This bus currently is called MOST. This will be gradually will be replaced by Ethernet as well, because there's no difference inside your car or inside your house. Okay. And today, the European car maker already lead the way. We already shipping products to the head unit inside the car, which consists of all the entertainment center, the GPS system, DVD player, and so forth. We think that the Ethernet is going to go inside the car in a couple more years. And even though today we had only a few customers, but in the future we believe that more and more automotive customer will adopt this Ethernet technology. Why we think that Ethernet is better than most? Because Ethernet is an open standard and has been used in almost everywhere. Your PC, your DVD entertainment center, and so forth, even in the industrial control. And it can run from 10 megabit all the way up to 10 gigabit. And most today can only run from 25 to 150 megabit. And volume-wise, we're shipping hundreds of millions parts per year with Ethernet, compared to just a few million chips per year with most. And there are many suppliers for the Ethernet products. On the most side, there's only one company doing that today. And therefore, we think that the cost will be much lower with Ethernet, which is probably very helpful for automotive customer as well. And cost is always the issue for any system. And we announced this, it's about 3 products qualify through the AEC Q100 for the automotive industry. That's the basic requirement. And we announced that the last Electronica in 2008, and was well received and was on the cover page of many magazines in Europe. I'll just give you one slide to show who we are, since I've talked a lot about Ethernet. We are we founded in 1996 as a Canadian Communication, and acquired by Michael in 2001. And we are famous in using a mixed signal architecture to implement all the equalizer required in the Fast Ethernet products. And one of the special things we did is we used the standard CMOS process to implement this mixed signal product. So we offer very low power and small die size and low cost. And in this year, early this year, there's a consortium called Geneva, foreign and headquartered at San Ramon in California. This alliance is a nonprofit organization, and their goal is to develop a in-vehicle infotainment system. And they invite all the semiconductor company, the car company, software company to develop a platform so that everybody can use this platform as a base so that they can get to a final product quicker. So you don't have to reinvent the wheel. Currently, we had a lot of, the membership is growing. You can see that we had BMW, we had GM, we had silicon company like Intel, Freescale, and a lot of software company here as well. Of course, Micro is here too. And just give you an example of the platform, how it looked like. It's based on Intel Atom processor. And also the companion chip here is Xilinx FPGA. So it had provide the video, HD, audio outputs, and also offer Ethernet connection here. So that, and also had a lot of connector here, like the USB and PCI Express, hard drive. And so it's very flexible, so that almost anything you wanted is here. And the automotive company can build on this platform and come up with something unique for their particular product. But it's a very good baseline to develop new products. And this is the physical board. And of course, there's a chip here that the Ethernet switch that developed by Michael. It also can support all the Linux, so it's a free software, very easy to use. The other product, the emerging market that we think that is coming is the smart grid. Since everybody know that we have energy crisis, everybody try to save energy. The smart grid is including everything, even the street lights to your heating and AC equipment inside your house. And there's a lot of smart appliances built in for the house today that can actually can connect to your home network so that you can detect how much power you're going to use when you use your wash machine. And worldwide, there's a big smart meter initiative. According to the U.S. Federal government, if you just adopt the smart meter in your house, you can save almost 5.8% of the power. And today, there's about 5% of the 140 million households are using a smart meter today. And also in Europe, they predict that by 2014, there will be 96 million households will be using smart power meter. And Sweden this year is the first country in the world that they are using 100% smart power meter. And UK will follow that. By 2020, there will be about 26 million. So I think it's a worldwide trend that people want to save power, save energy. And how this works, if you look at the smart power meter, it basically, this meter, the power meter, it will record the usage of your power and then send through this gateway and to the internet. And it will allow the utility company to monitor your usage. Or if you allow them, they can turn off your air conditioner when you're on vacation if they detect that something is on there and wasting a lot of energy. And this is the PCB of the smart meter, and this whole board can fit into this smart meter. Of course, you probably would know that this chip is manufactured by Dongbu High-Tech. So in conclusion, Ethernet is really everywhere. It's moving from your house to your car to your office, and it will continue dominate the IP network. I'm showing you this picture that you can see is everywhere, even in space, because our chip also go to the space shuttle. Thank you very much.